What's good, YouTube? It's Alma with the sauce, and I'm back with another video. In this video, we're going to be going over arc length and sector area. I'm just going to show y'all how to do them, and then in the next part, I'll do some examples. So get your pencil, get your paper, and let's get into it. All right, so first of all, arc length simply just refers to the length from A to B along the circle. And so the way you solve for it is basically you think of it as the arc length being just a portion or a fraction of the entire circumference. So just like how a fraction is part to a whole, the arc length is the part, and then the whole distance around the circle is the whole. And so what we can do is we can write that as a fraction. So the length of arc AB is the part, and then the whole circumference or the distance around the circle is the whole. And we already know that's 2 pi r. And another way you can think of it is this angle theta is also a portion of the whole distance around the circle, which is 2 pi if we're talking about radians, or 360 if we're talking about degrees. Now that you have all 4 parts to your proportion, you can just go ahead and cross multiply, and then that'll show us how to solve for the arc length. It'll be the arc length times 2 pi. So I'll say the length of arc AB times 2 pi. Again, that's the number of radians, equals 2 pi r times theta. And then if I'm trying to get the arc length by itself, then I just divide both sides by 2 pi. So then my 2 pi's are going to cancel out, and so I'm left with the length of that arc is equal to r times theta. Alright, so when it comes to sector area, the way you solve for it is basically the same way as arc length. That's why I'm doing them both in the same video. But first of all, what a sector is, it just refers to the shaded part in this circle. So it's like just how the arc length was a portion of the whole circumference, this time the sector is just a portion of the whole inside of the circle, which is the area. So if you think of it as part of a whole, the part is this sector, and then the whole is the whole inside of the circle, which is just the area of the circle. So if we want to let this be the area, the whole would be pi r squared, which is the area of the circle. So now to solve for the sector area, you would do it the same way you did arc length, just cross multiply, and that's it. So one thing when it comes to dealing with radians or degrees, you're basically just going to use whatever you're given as theta. So if they give you the problem in degrees, go ahead and use 360. But if they give you theta in radians, then just do 2 pi. All right, so this time I'll do it as if they gave it to you in degrees. So the area of the sector times 360 would be equal to your theta in degrees times the area of the circle, which is pi r squared. And then of course, to get A by itself, you just divide both sides by 360, and that'll give you the area of the sector. All right, so those are basically the 2 formulas you're going to use to solve for the arc length and the sector area. So make sure you stick around for part 2 for some examples. I'll see you in the next video.